Welcome to the Deep Dive. Today, we're looking into some excerpts from a source called Estimating Crop Yield, an integration podcast.
Right. And this source, it lays out a pretty clear aim, creating a short, maybe 3 to 4 minute audio piece. Seems targeted at college students.
And the core idea is, well, it's connecting a pretty fundamental math concept, integration,
Mm.
from differentiation and integration
hmm
to a really practical issue in, of all things, food science.
Exactly. The source gets specific, saying the application is, well, using this math to estimate the total crop yield over a whole season. It's really about showing how calculus, which can seem abstract, solves, real-world problems.
Okay, but then the source throws in a bit of a curveball, doesn't it? It mentions linking this whole yield estimation thing to something just labeled scope.
hmm
And this seems important. It talks about needing a suitable mathematical formulation that relates to this scope.
Yeah, that detail is pretty telling. It suggests the context, what they're calling scope, really dictates how you actually set up the math. It's not just, hey, let's use integration.
Right. It's applying it within certain limits or boundaries.
Precisely. So, okay, let's try and unpack this a bit. What's the source really telling us about, connecting theory and practice?
Good question.
Well, I mean, the main thing is showing integration works for this, estimating total yield over time. It makes sense, right?
Okay.
Integration is basically about summing up changes over a period.
So if you know the rate the crop is producing yield, like moment by moment,
If you have that rate function, integration lets you add all that up across the whole season to get the total amount.
okay, so it captures that sort of continuous growth, not just snapshots.
You got it. You're integrating that yield rate over the time period the season to get the total quantity. It turns that ongoing process into one number.
But like you said, it doesn't just stop with use integration. There's the scope part
Yeah.
and needing a suitable formulation. What's that about?
Well, that really flags something important about applied math, doesn't it? You can't just grab a formula off the shelf.
Right.
You absolutely have to understand the problem you're applying it to. What exactly are you trying to estimate? Is it one field, a specific crop variety, under certain weather conditions? What are the bounds?
Ah, okay. So scope is basically code for needing to define the exact problem, the context, before you even know how to apply the math tool correctly.
That's exactly how I read it. Yeah.
Yeah.
You could have the best mathematical tool in the world, but if you haven't clearly defined the problem's domain, its scope, your application might be way off or just plain wrong.
So a different scope,
hmm
maybe a different region or a different time period, might need a whole different setup for the integral.
It certainly could, or different data inputs, maybe different assumptions built into the model. It highlights that defining the problem is, well, it's just as critical as knowing the calculus itself.
That makes sense. The calculation part is almost secondary to getting the setup right.
Absolutely. So the source, even though it's aiming for brevity, it kind of implicitly teaches that applying math isn't just plugging numbers in. It's about really understanding what you're calculating and why, and for what specific situation.
Okay, so boiling it down. This source is using crop yield estimation, not just to teach integration, but also as a lesson in, like, the practical side of applying math.
I think so. It links the calculus concept to a tangible process growth over a season, but it crucially adds that layer of needing to define your scope, your boundaries, to pick the right mathematical approach.
So to wrap this up then, the source wants to show college kids how integration helps estimate crop yields. But it also sneakily reminds us that you need to define your problem, that scope, to find the right formula.
Yeah, it's a little dose of reality. Real-world problems, they don't usually come neatly packaged for you.
Right. And that kind of leaves us with a final thought for you, the listener. The source stresses needing a formulation tied to a specific scope. So think about this. How crucial is it really whenever you try to apply any theory to practice to first pin down the exact problem, the scope, before you even start looking for tools or formulas? What does that imply for how you approach learning or even just solving everyday problems?
Definitely something to think about.
Thanks for joining us for this deep dive. We'll see you next time.